Welcome, students. Today is the second lecture under the subjects General Maths. O level. Yesterday, the first lecture, we introduced the subjects General Mathematics. We had just mentioned that general mathematics lays the foundation for any other aspect of mathematics to fall in. Today, we are going to look at three important subtopics still under the introductory aspects of general mathematics. First of all, we are going to look at the importance of mathematics to mankind. After that, we look at the various classifications of mathematics. Then after that, we look at how to study and understand mathematics. Now, of what importance is mathematics to mankind? Importance of mathematics. Now look, 1. In money-related transactions, example, banking sector, etc. Mathematics is the second language. Hence, we have business to commercial mathematics. If you go to banks, be it in a particular country, like let me say an English-speaking country, the language you see there is the English language, and the second language of operation of that banking sector is mathematics. So all those financial figures that you not see in banks is always expressed in mathematics. And that's why even we have a branch of mathematics called business or commercial mathematics. 2. In measurement, example, distance, speed, area, volume, perimeter, etc. Mathematics is also the second language. When you want to measure the distance between one location and another, you want to find out the volume of a particular thing. You want to find out the perimeter of a system, of any particular object or what. All these things are expressed in mathematics. 3. In areas of applied mathematics like chemistry, physics, statistics and decision making, planning and budgeting, computer science, maths is highly applicable. Many things which you do in mathematics. Mathematics is applied, we have chemistry, we have physics. All these subjects I mentioned here, mathematics is always the second language. First language is language like English language, or French language, or German language, or Russian language. After that, the universal language next, which can now be used to express that particular subject, be it chemistry, physics, statistics, planning and budgeting is mathematics. 4. Various measuring machines like blood pressure machine, high blood pressure machine, sugar level machine, thermometer, speed of the wind, etc. All these readings are expressed in mathematics. 5. Certain problems of mankind are solved or confirmed through mathematics. Example, certain problems you come across in life have been solved through mathematics. For instance, the popular formula, E is equal to mc squared. This formula was developed by Sir Albert Einstein, one of the scientific legends that ever lived. It was through mathematical manipulation that he derived this formula. This formula, E is equal to mc squared. Then many years later, this formula now was later confirmed practically in the laboratory by the Curies. Marie Curie and his group confirmed that this formula, which Albert Einstein developed or discovered mathematically, was finally confirmed in the laboratory by the Curie family. And this is the formula that was used to manufacture the first atomic bomb around 1945 or thereabout. Number 6, natural occurring constants are expressed in mathematics. We came into this world to meet certain constants that come out naturally. As we delve into mathematics, general mathematics, we'll be coming across some of them and we see how they came about. Pi is equal to 3.1414 non-stop. It continues. It's continuous. What did pi tell us? Anything that has the shape of a circle, if you measure the distance around this circle, the distance around is called the circumference. You divide it by this point, by this distance passing through this center, called the diameter. Once you divide the circumference of anything that is circle by its diameter, this number 3.14 that must come out, and is given the name pi. In the study of slow growth, things that grow naturally or that grow bit by bit, for instance, the growth of materials and some other things, we also came across another constant called exponential constant, E, and it has this value 2.74 non-stop, and the rational number also. Now, the acceleration due to gravity, G, in physics, we come across it. We even derive how it came about. It's given by G is equal to 9.81 meters per second squared. The speed of light is given by 3 times 8 to the power 3 times 10 to the power 8 meters per second. All these are natural constants that come out in mathematics. And all these constants serve a lot of purpose or the other for mankind. There are many of them. We come across many as well as time goes on. Number 7, technicians like tailors, masons, carpentry, etc. use technical instruments like tape, plumb, etc. All are expressed in mathematical terms. Hence, we have technical mathematics. There's also a branch of mathematics called technical mathematics. For those students that are in technical colleges, they have what we call technical mathematics, just as we have a commercial or business mathematics. Number 8, more areas of applications of mathematics exist in its classifications. We are going to look at the classification of mathematics very soon, and we will see how areas, all the divisions of mathematics, how the various applications of mathematics that goes on in these areas. And finally, in areas of manufacturing of spare parts, designs, etc., precision measuring instruments like calipers, micrometer, screw gauge, etc., are used in measurements. This is the reason why one spare part or the other will lap onto another. If you want to, in the manufacture of certain spare parts, this is a spare part to be manufactured. This one is another spare part to be manufactured, but it is expected to lap into this other one. In all these areas of manufacturing and designs, certain precision measuring instruments like calipers, micrometer, screw gauge, and so on are being used. And all these things are measuring instruments that expresses their value in mathematical terms. When we start physics, we will come across these precision measuring instruments. So these are the various importance of mathematics, which mathematics is. That's why we say that mathematics is a universal language. And mathematics has helped us a lot to understand the universe, to understand more about the world we live in, and so on. Now, let us move further and look at the various classifications of mathematics. classifications of mathematics. Very, very important. One, mathematics can be classified this way: arithmetic, algebra, geometry, and trigonometry. Among these classifications, this is the classifications we use to class. This is the way we classify mathematics at O level. This is O level classification. Some other textbooks will classify it in different ways, but these are the principal classification of mathematics at O level. After that, I will give you the next classification of mathematics at higher level, after O level. But at O level, this is the principal way we classify mathematics. What is arithmetic? Arithmetic is the use of what? During our first lecture, mention was mentioned of natural numbers, whole numbers, integers, rational numbers, irrational numbers. All these, all of them, belongs to what you call all of them real numbers. Are real numbers. Big R. And yes, during our first lesson, this was also expressed, also presented on a number line like this. 1, 2, continues non-stop. -1, -2, continues non-stop. This is the real line. All those aspects of mathematics that involve the use of these real numbers is referred to as arithmetic. It is the foundation of mathematics. It comes first before any of the other ones we follow. So as we go further now, we will now look at the various operations we can carry out in under arithmetic. So many topics we come across under O level can be grouped as arithmetic. So all those types of mathematics that involves the use of real numbers, whether 1 or 2 or 3 or fractions, we group them under arithmetic. And all those numbers belong to this set of real numbers. Now, after arithmetic, we get another mathematics also grouped as algebra. Algebra now means what? Instead of using real numbers like 1, 2, 5, -2, -8 to work, we now use letters and symbols. For instance, we can say we now use letters like X, Y, Z. This is now what we use. For instance, you can add, under arithmetic, you can add 2 plus 5 to get 7. Under algebra, you can add X plus 2X, or say 3X plus 2X. X, they're like terms, you get 5X. Under algebra, you can when we come to algebra to explain, X plus Y. S is different, Y is different, they are unlike terms, so they cannot be what? Added. So instead of under arithmetic, you use real numbers like 1, 2, 3, 4, and all want to work. Under arithmetic, all these numbers can be added. Under arithmetic, numbers like this, all these real numbers can be added. They can be subtracted. They can be multiplied. They can be what? Divided. Example, 6 plus 8. 10 minus 4. 2 times 6. 9 divided by 3. 14, 6, 12, 3. This is under arithmetic. But under algebra, we are no more going to be using these things, this physical thing. Now, this time around, we are going to be using symbols. Or most occasions, alphabetic symbols. This one now, it can be written like this. 6x plus 8x equal to what? 14x. I have used x. I can use anything like 6 boys plus 8 boys equals to what? 14 what? Boys. 6 boys plus 8 girls give me what? Unlike that, this is girl, this is boy. They cannot be added. Cannot be added. Unlike terms. Here, 10 minus 4. It can be 10k minus 4k equal to what? 6k. So, in short, algebra is more or less a generalization of arithmetic. Instead of using real numbers to work, we are now using letters of the alphabet or symbols. And this algebra is a very, very important gateway into mathematics, because this algebra will now lead you into what we call functions. We will come to that. Now with functions, now you can carry out operations on functions. Calculus and other topics operate on functions. The third division of mathematics is the one we call geometry. This is the study of shapes. We came into this world to make certain shapes of different forms. If you look around you, wherever you are, you can see certain shapes like circle. You see certain shapes like rectangle. You see certain shapes like square. We have other shapes, triangle, and so on. So the study of shapes is what geometry is all about. We will come to that at the right time. And finally, the last classification of mathematics is trigonometry. Triangle and the angles that come with it, but it's beyond that. When we have the angle formed, the space in between two intersecting lines give us angle. Angles which are always in degrees or radians. But the story of trigonometry now has gone beyond triangle and angles. We can use trigonometry now to explain things like heartbeats, waves, something like waves. Something like doing like this. Heartbeats, electricity. We can use trigonometry now to explain all this. We will come across all this both in mathematics and mainly in physics. So all these are the various principal classifications of mathematics at O level. But at advanced level, at high level, starting from further maths, A-level mathematics, degree mathematics, mathematics is now divided into two forms, into two parts. These are not division of mathematics. These are at higher level. Higher level. Higher level, I mean, here starting from further maths or additional maths up to A-level mathematics. Now we divide mathematics into two. Thus, pure maths, mathematics, and applied mathematics. What is pure maths? Pure mathematicians look at the world where we live in. Start formulating mathematical models that can be used to solve various problems of man. As at the time they are formulating it, they may not know where such formulation can be used. But they only know that that type of thing they're formulating, as time goes on, can solve one problem or the other for man. As at the time they are formulating it, it's called pure mathematics. But when that pure mathematics they formulated is now later applied to solve the problem of man, either applied in the area of chemistry, or applied in the area of physics, or applied in the area of engineering, or anywhere it is being applied to solve the problems of man, now it becomes applied mathematics. For instance, ordinary arithmetic, which look at this question. A man left a legacy of $8,000 to be shared among his 3 sons in the ratio of their age. Their age is, one is 14 years, the other one is 10 years, the other one is 6 years. How much does each get? You can see these are applied mathematics. What is being applied here is arithmetic. We will come across more of such. One thing about this thing is that, for instance, the mathematics guiding the operation of computer had long been discovered under pure mathematics thousands of years ago. It was after thousands of years now that those mathematics designed under pure mathematics was now being applied to the operation and development of computer. Something that is developed today under pure maths automatically one day may turn out to become an applied maths. That's why those mathematicians that work on pure maths are called pure mathematicians. While those that apply what pure mathematicians have done to solve one problem or the other for mankind, they are called applied mathematics. If you look at maths A level, you can see this is maths A level. A is pure maths. This pure maths. This maths A level is divided into pure maths and applied maths. Pure maths is this. This calculus is under pure maths. I know why I separated it. Because calculus is a special subject. This calculus is under pure maths. Statistics too, statistics and mechanics are applied aspect of A-level mathematics. So we have seen the two areas under which mathematics can be classified. First one is O-level classification and higher level classification. Under O-level classification, we have arithmetic, which is the operation of the real numbers we talked about during our first lesson. Algebra, that generalization of arithmetic gives us to algebra. As you use 1, 2, 3, 4, 5, 6, and the real numbers to work on arithmetic, with under algebra, we're now using letters X, Y, Z, and other symbols. Geometry is the study of shapes, different types of shapes we came across to meet on Earth. If you look at the moon, what's the shape of the moon? Look around you, see certain shapes like buckets and other things. We will come to that. What we call plane shapes and solid shapes. The trigonometry, we talk about the angles, the angle in between two intersecting lines, including triangle. But trigonometry has gone beyond that, as it is now being used to explain things like waves, electricity, heartbeat, and other things that move, that are sinusoidal, all other things that move like this. Now, on the higher level, another way we can classify mathematics at higher level is under pure maths and applied maths. Those that write out, they look at mathematics, start writing out certain things that one day, one time, human beings will be in need of it. At the time they're writing, they may not even know when and how that will be used. Some of them may stay 100 years or more. For instance, mathematics guiding the operation of a computer today was developed under pure mathematics thousands of years ago. But today, those things are not being applied in the computer to write programs for computer and to design computer. Those applied mathematics can now be applied to other areas of life. We apply it in chemistry, we apply it in physics, apply it in engineering, apply it in business, and so on. That brings us to the end of classification of mathematics. Finally, for today, let's look at, we are going to look at this one briefly. We are going to look at it briefly. How to study and understand mathematics. Mathematics is unlike any other subjects you can see in the school curriculum. It's a bit different. So its approach is advisable that each approach should also be different for a better understanding of the topic. One, some students believe that the subject mathematics is hard. Once you are biased about it, once you have that notion, you are on a wrong track. Once you have the impression that mathematics is difficult, you are already biased. So the earlier you remove such a thing from your mind, the better for you. Two, mathematics is a subject. If you leave it for a long time, it will leave you. Especially as a beginner. Keep on practicing. Let your hand be moving. It's an important law of nature applies here. Practice makes perfection. This is very, very important in mathematics. Someone like me, if I leave mathematics, even for 10 years, every time I come back to it, to understand it. But as a beginner who is learning mathematics, don't keep away from mathematics for a long time. Keep obstacling problems. Let your hand be moving. Third, very poor foundation in mathematics is another problem. Very poor foundation. Once, like this topic I'm teaching in general mathematics, I started it from first principle, from the beginning. So I advise that you follow me as I move along. Once somebody has had a very poor foundation in mathematics, maybe during your primary school, poor foundation, early secondary, poor foundation, for that person to turn a U-turn at the end of the secondary school and become perfect in mathematics, on most occasions, is always very difficult. Four, mathematics should be approached in an organized manner. Mathematics should not be approached in a haphazard way. For instance, a subject like biology. A teacher may teach cells today in biology. On another day, when the teacher is trying to teach blood, somebody who was not here when cells was taught can follow when blood is not being taught under biology. But in mathematics, most topics are interrelated. You must study topic A before you follow topic B. You must be there at the beginning of that lesson, or during the first time the topic was introduced, because you have followed the next one. For instance, it's advisable, if you want to study graph, it's advisable you have to study scales first. Five, some mathematical problems exist in worded form, in form of words. And for you to solve such a problem, you must read that word, be it English language you use to frame it, or French language, or German language, or what. After framing it, now you'll be in a position to decode it and convert what that you have read into a mathematical equation. Then you solve. Number 6, cramming. We don't encourage cramming in mathematics. In as much as we don't encourage certain cramming in mathematics, but as a mathematician, certain things must be in your brain all the time, even if you are asleep. For instance, when the circumference of the circle, 2 pi r, it was in your brain. You can't call it whether it's cramming or not, it was in your brain. What is the area of the circle? Pi r squared. This thing is something you must know. Be it in your mind or in your brain, any time. We can't call this one cramming. This relationship, as you go on further, you see this relationship. Sine squared theta plus cos squared theta equal to 1. That's what I'm trying to say, that certain topic, certain formula must be in your brain all the time. Area of a circle, area of a triangle, half base times height. We don't encourage cramming mathematics, but these ones must always be in your brain, even if you are asleep. These are the basic ones. Even you can even devise certain tricks which you can use to remember some of this formula. Number 7. If the topic that confronts you, or the question that confronts you, involves drawing diagram, please try to draw the diagram. Don't start solving without drawing the diagram, like anyone that involves diagram. Because if by the time you draw the diagram, the question now will become clearer. And you will not see the approach you are going to take. Number 8. As a human being, you should be in a position to imagine it physically. Once you hear of the term pyramid, cone, frustrum, sphere, cylinder, once you hear of this information of this thing, in the real world, you must know how these things look like. And once you know how they look like, then you draw the diagram. For instance, cylinder. Everyone knows that cylinder is this, like this. Look around you, certain things around you that is the shape of a cylinder. Container of most beverages, tin of milk, most tin of milk and all whatnot is the form of cylinder. So you mention, if you can mention this is cylinder, sphere, this, but things around you, you don't understand that those things are cylinder or frustrum or sphere or whatnot. That is cramming. The person has not known the topic. If you hear of how 1 kilometer, 1 meter, you solve problem involving this and get 1 meter, 2 meters, 3 meters. But in the real world, you don't know how big 1 meter is. It is very, very wrong in the real world. This is also cramming. 1 kilometer, you solve mathematics, get 1 kilometer, but how far is 1 kilometer? You must have an idea how far 1 kilometer is in the physical world. For instance, this thing I'm holding here, this is 1 meter. This is a meter. This is 1 meter. Try to understand a topic from first principle. Understanding a topic from first principle is very, very important. For instance, when you understand something from first principle, look at, for instance, then understand something from first principle. Look at this. This is what I can call a keyboard. The total surface area of this keyboard here is 6A. But assuming the person, if his total surface area is 6A, and the add extra question, assuming the surface of this thing, the top, is missing, what then should be the total surface area? The total surface area of this thing is 6A squared. But the question goes ahead to add one more question. Add one question. Assuming the surface of this thing is absent, what then should be the total surface area? If you got this one, but when they add the second question that this top surface is missing, what then the thing is, and you cannot get it, surely what you have done is cramming. You don't understand it. Number 10. Some students find it very boring to be reading the theoretical aspect of mathematics. As when you are comfortable with textbook, and you see the theory right up before you see the calculation aspect. Please try to read that theory as much as possible. So students will bypass the theory, jump into the calculation aspect. It's when you are reading the theory that you are not being equipped to understand the rudiments of that topic. One should be in a position to have knowledge of many topics in mathematics. In geometry, the more the number of theories you know, the better off you are in geometry. In geometry, the solution of a particular problem may involve applying 2 or more theories before you get the correct answer. A problem on area, volume, variation eventually may boil down to become simultaneous or quadratic equation. Always keep a note where you write down certain formula and tricks, although they may already be existing in your textbooks. Some very important mathematical problems should be copied into this note. This serves as a reference note. Number 12. Mathematics. Some teachers present mathematics to some students as solve and get answer. This is wrong. Every mathematics and technology has theory behind it. Ensure you acquaint yourself with the theory behind any mathematical topic. Because it's only when you know the theory behind what you are doing that as you solve, your hand will be moving. In addition, and finally, as you're solving a particular problem and you know you're on the right path, always try to exhibit maximum confidence in yourself as you solve along. So, these are just a rush of how to study and understand mathematics. These are just guides. It varies from individual to individual. But as I handle you on this topic, general mathematics, you will get to know more and more tricks. That marks the end of the second lesson under general mathematics. We'll meet you some other time. Thank you.